June 21st, 2016. I'm in this book right here, How I Killed Pluto, written by Mike Brown. Page 23. Ceres and Pallas, I think that's how you pronounce it, though considered full-fledged planets, had a few puzzling properties. While all of the other planets were well spaced in their orbits around the sun, Ceres and Pallas were, in the cosmic scheme of things, right on top of each other between Mars and Jupiter. They were different from the other planets in other ways too. The recently discovered Uranus was too faint to be seen without a telescope, simply because it was so far past Saturn. With the aid of a telescope, though, the green outline of the disk of Uranus was apparent. But Ceres and Pallas were closer to us than Jupiter, closer than Saturn. They could not be seen without the aid of a telescope because they were far away, but simply, not because they're far away, but simply because they were so small compared to all the other planets. They were so small, in fact, that even with the best telescopes of the day, they looked like little points of light. Herschel, the discoverer of Uranus, wanted to preserve the uniqueness of his own discovery. I suspect, coined the term asteroid, aster in Greek for star, as in astronomy, while oid means like, to describe these new objects. To Herschel, Ceres and Pallas weren't like real planets with their visible disks. They appeared star-like instead. Here's another one of the weird things about astronomy, is that when they were looking at the planets, they described them as being disc-shaped. Now, we all know that the planets are spherical structures. They're spheroids, oblate spheroids. But why on earth would they refer to these things as being discs? As if you see the disc, and then if you turn it sideways, it looks like a dish plate? You know, why on earth would they use that kind of terminology? I have no idea. Then I thought, well, it appears to be a disc. But that's one of the big problems with astronomy, and why it was mismatched and crazy all throughout many hundreds of years, is because they looked up at the stars and they only wrote down what they were looking at. They only wrote down what it appeared to be. Now, little did they know that kind of mentality is very damaging. You don't look at the stars and write down what they appear to be, because what that does is make it hard for people to understand what it is they're looking at. You have to be able to use a little bit of imagination, creativity to explain exactly what it is you're looking at. So the fact that they refer to Uranus and Jupiter and the Sun as being disks, they're not disks, they're spheres. It's that same problem that they had with the ice giants, Neptune and Uranus. They say, oh, they're big ice balls. No, they're far away from the sun. Of course their outer atmosphere is going to be cold. But in the interior, they're really, really hot. They're hellish interiors. So that's the huge problem. Another huge problem was that astronomers these days refer to metals as anything being heavier than hydrogen and helium. So oxygen is a metal, nitrogen is a metal. Things that are clearly not metals are referred to as metals. So that's the second thing that really throws astronomers off, but they don't realize how powerful language is. They have to use correct terms for things if they're going to be explaining what they're talking about. And that's a huge issue I realized here as well. Here's another passage for you. Pluto was found to go around the sun in an elongated rather than circular orbit, and while all the other planets orbit the sun in a flat disk, there's that disk word again, Pluto was found to be tilted by almost 20 degrees from the rest. Pluto also looked different. It was so small that you couldn't tell it was a planet at all. In fact, it appeared star-like. Some astronomers didn't want to call Pluto a planet. Shouldn't it be just called an asteroid instead? By then, though, the word asteroid had lost its literal meaning of star-like, and instead referred specifically to that belt of objects between Mars and Jupiter. Should it be called a comet? Comets can have elongated and tilted orbits like Pluto's, but none had ever been seen so far away. And the word comet from coma, Latin for hair, specifically refers to the fuzzy appearance of comets in the sky. Pluto was not fuzzy. It looked like a star, albeit one that moved. Though it looked and behaved like no other planet known, there was no other way to classify it, so it became accepted as the 9th planet. It had the element plutonium named after it, and remained unchallenged for almost 70 years, a tiny lonely oddball at the edge of the solar system. The planet with ice spires, the planet with an orbit so extreme that it couldn't even fit on my poster on the wall, the incongruous period at the end of the solar system. And there's that passage, but on the end of 28, the meat and potatoes of this talk is going to be presented. If Ceres was to be thought of as just the largest of the vast collection of asteroids and thus not a planet, why should Pluto not suffer the same fate? After all, was a planet? I have the solution for this. A planet is a differentiated structure with an iron-nickel core. It has to be differentiated, it has to be massive, and it has to have an iron-nickel core. If it's undifferentiated, then it wasn't a planet. It is the remains of a collision event between two objects. So all you have to do is take the moment of inertia measurements of Ceres and Pallas and Pluto and see if they come out to show that it's differentiated in its interior. Because differentiation equals it took time to form that object. Lots and lots of time. Meaning it was star-like at one point. Mind you, it might have been a very fastly evolving star, a star that had its atmosphere ripped away and couldn't have formed a core fast enough in order to be on par with the Earth. Earth would have been formed by a star that hadn't had its atmosphere ripped away as fast as Pluto or Ceres. But if Ceres is undifferentiated, if it's just a large rocky ball, and chances are it's the remains of an impact event. Same with Pluto. Same with this new dwarf planet called Xena, which is, I think, SB 303 or something like that. I'll have to look it up again. But that's how we can define them now, utilizing stellar metamorphosis. And as well, I wanted to point out that it's a privilege to be able to read books like this and be able to understand, you know, on a whole nother level, what happens to stars and how planets are formed. Because I get to see where all these assumptions are that they're making that are getting in the way of them understanding nature. It's kind of weird. I get to look at it with new tools, with new ideas. And it just sucks that even if I were to try to get a hold of this person and tell them how to accurately define these objects, I wouldn't be able to. I would just be ignored. Alright, well, I guess that's enough talk for today. Hopefully you can read this book. Go ahead and check it out for yourself. There's a lot of good storyline in here about why he made decisions that he made. And it definitely brings to light a lot of the facts of astronomy and why things are the way they are today. Alright, later y'all.